Hello and welcome to Rointe. In this presentation, we learn about sizing the Rointe radiators and towel rails to a specific installation to ensure that we obtain the maximum energy efficiency and the optimum heat output. So why is it so important to size the radiators correctly to their environment? If the radiators are correctly sized to the environment, they will ensure that not only will the premises be heated correctly with a consistent consumption, but the energy-saving characteristics of the Rointe system work to their optimum levels below the nominal power of the installation. The Rointe method to calculate heating for a property relates to climatic zone, room size, and number of elements. There are two elements we need to take into consideration before we are able to work out the correct size radiator for a room. Firstly, we need to work out the climatic zone the installation is situated in, and from this, we can work out the Rointe thermal coefficient. The climatic map of the UK divides the UK into different heating zones, from mild to extra cold. Each zone has a climatic coefficient based on the UK weather map, and we must also consider whether we measure a room in meters squared or meters cubed. The Rointe thermal coefficient is the coefficient developed by Rointe that serves to relate the number of elements necessary to heat a room. The example we have taken is for a property situated in a cold climate zone. We take the BTU value for this zone, being 476, and divide it by the BTU value of one of the Rointe heating elements, being 595. And we end up with a figure of 0.8. This means that 0.8 elements are required to efficiently heat a meter squared area. To calculate the necessary radiators required, we must also establish the height of the ceiling. If the ceiling is less than 3 meters high, we can use the meters squared coefficient, and if the ceiling height is above 3 meters, we must use the meters cubed calculation. In this table, we show not only the climatic coefficient for each zone, but most importantly, the Rointe thermal coefficient for meters squared and meters cubed. With this information, we can calculate the number of Rointe elements required to heat a room. In this example, we have taken a room of 16 meters squared in the cold climate zone. The calculation is 16 meters squared multiplied by 0.8 elements, which equals 12.8. Therefore, a minimum of 12.8 elements are required to heat this room. This would ideally be one Rointe 13-element radiator. If we take an example of a similar size room in a cold climate zone, but with a ceiling height of 3.5 meters, we need now to use a meters cubed calculation. 16 meters squared by a ceiling height of 3.5 meters is 56 meters cubed. So therefore, 56 meters cubed by the RTC, Rointe thermal coefficient, of 0.26 equals 14.5, i.e. 14.5 elements required. Therefore, 15 Rointe elements are required to heat this room. This would ideally be one 15-element Rointe radiator. As part of the Rointe range of digital integral heating system, we also offer unvented, mains pressurized digital hot water cylinders in 5 sizes from 50 litres to 200 litres, i.e. 50, 75, 100, 150, 200 litres. This table demonstrates the size of the cylinder required according to the use and the number of people. If there is any doubt, please contact our technical department, who will be happy to assist. Rointe have towel rails in both the Kyros and D series ranges. The tail rail sizes are recommended by area, and sizing is also dependent on the finish of the tail rail. This example shows a bathroom with a surface area of 8 square meters. We recommend a 750 watt Kiros in white or a 750 watt D series in graphite, white, or any rail color. Again, if there is any doubt, please contact our technical department for advice. Once we are able to work out the correct products required for a specific project, we can then calculate the energy consumption, which allows us to know the real energy usage and saving. Before we are able to calculate the consumption of a product, we have to understand about nominal, effective, and available power. So what actually is nominal power? Nominal power is the maximum power that a product can demand. For example, a 1.6 kilowatt Rointe radiator can demand 1.6 kilowatts. The energy usage of a product is calculated using the effective power, which is the power it uses in real time. The power that is not used, i.e. the difference between the nominal and effective power, is called the available power. With our fuzzy logic technology, at 21 degrees, our radiators typically use just 38% of the nominal power, and therefore do not use 62%. This calculation can be used to work out energy usage over a given period. This example shows the energy usage of a 13-element Rointe radiator, which has a nominal power of 1.43 kilowatts. The effective power of the radiator, with the 38% usage, is 0.54 kilowatts. The calculation is therefore 0.54 kilowatts by 12 hours multiplied by a cost of 12 pence per kilowatt hour, which equals 78 pence per day. So this radiator running for 12 hours will cost 78 pence. We then take the 78 pence, multiply it by 30 days to give the monthly cost being £23.40. To work out the running cost of a 100-litre Rointe unvented mains pressurized water cylinder, we take the nominal power being 2.4 kilowatts and multiply this by 19%, which is the effective power, giving us a total of 456 watts per hour. Over a running period of 24 hours, the water cylinder will use 456 watts by 24 hours, which is 10.94 kilowatts. Using 12 pence as the energy cost per kilowatt hour, the water cylinder will cost £1.32 per day. Over a 30-day month, it will cost £39.60. Using the Rointe house as an example, the nominal power is 6.88 kilowatts, and the effective power is 2.61 kilowatts. Running this over a 12-hour period, the daily cost is £3.60, and the monthly running cost is £108. Thank you for taking the time to view this presentation. Please refer to the Rointe, Kiros or D-Series product catalogues or visit our website at www.rointe.co.uk for more information.